Graph quadratics in factored form. Okay. So we're going to graph this function. It's already in factored form. Eventually we're going to work on having these in standard form. Then you have to factor them to this state and then graph it. So for now, I'm going to snip this and do some math to find my vertex and x-intercepts. So first thing we're going to do, find the x-intercepts, or the zeros. All right, and to do that, remember we take each of these binomials and set it to equal 0. Do the math, we're going to add 2 to both sides, and one of our zeros is at positive 2. And the other one, we set to equal 0, and we did that, and we already have our answer. We have one 0 at 0, or the origin, and the other 0 at 2. Now what we want to do is find our vertex. Okay, so the x value of our vertex is our 2 zeros. So we have 1 at 2 and 1 at 0. You take them, you add them up, and you divide by 2. So 2 plus 0 is 2. Divided by 2 equals 1. Take this 1, so our x value is 1. We got to find our y value still for our vertex. To do that, we take this 1 and put it into the equation. So negative 6, and I'll make my x value in blue, so you know where that's coming from. That's this guy right here. And then we're going to do the math. Left in blue. Negative 6. This parenthesis 1 minus 2 becomes negative 1. And then we have negative 6 times negative 1, which is positive 6, times 1 stays at 6. So our vertex is at 1, 6, and we have 2 zeros. 1 is at 2, 1 is at 0. So first let's go graph our vertex at 1, 6. So 1, and then up to 6. And then remember, if we look at our image, we have 2 zeros. 1's at 2, and 1 is at 0. So go back to your graph, take your other point, this guy, and put it at either 2 or 0. And you can see if I flip it back and forth at 2 or 0, my graph is not changing. They should both be at the same spot. And one last thing is always look at your equation. Where's that? Here we go. Look at your a value, the value out front, and look at a concavity. The concavity here is what? It is down, because it's a negative number. So, looking at my graph, is my graph facing down? It is. So you can kind of check it before you actually hit, or leave the question. Let's do one more. I'll go a little faster this time. Okay, so once again, we're going to find our x-intercepts, or I'll write zeros this time. So our zeros is x minus 1 equal to 0, and x minus 9 equal to 0. Both these are a little easier. Okay, stop for a second, so I'm not sure where I exactly was. We are finding our zeros. Both these are kind of easier because you just have to add one to both sides here, and we get x equals 1. And this one is x equals 9, because you're adding 9. Cross, 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 cross. So we have our 2 zeros, and then we got to find the vertex. And to do that, we add our 2 zeros together and divide by 2. So 1 plus 9 is 10 over 2, and 10 over 2 equals 5. That's our x value. We take 5 and we plug it into the equation. So 3/8 times 5 minus 1 times 5 minus 9. So then do the work in parentheses. 5 minus 1 is 4, and 5 minus 9 is negative 4. So we have 3/8 times 4 times negative 4. So I'll evaluate this, which is negative 16. And then negative 16 times 3 gives me negative 48 over 8. And finally, that equals negative 6. So that's our y value of our vertex. So 5, comma, -6, and our zeros are at 1 and 9. So 5, comma, -6. Gotta move that one over a little bit. And we have 2 zeros, one's at 1 and 1 is at 9. And you can see once again, if I put one at 9, the other one defaults to 1, or back vice versa. And looking at our a value, it is a positive number, which means our concavity is up, and that's what we have here. And we're done.